Introduction to the command query responsibility segregation, CQRS. So CQRS is one of those latest trendy buzzwords that are popping up on, I think, every major web development related conference, and it's getting more and more popular. So today's presentation is first of many, and today I'll be talking only and specifically about CQRS, and in the next ones to come I will be talking about event sourcing, which is another pattern which can be used only when you have CQRS on your system already, and which is a great way to deal with changes of state in your application and how you would like to store your state of your application. And about domain-driven design, so an approach which strictly defines the structures to which you should put your logic in your application and where those structures should be located in your system. And besides that, CQRS is connected with terms like multiple data stores, NoSQL databases, and microservices. But you don't really need to know any of that to use CQRS in your application, but it's good to know that it's connected somehow. After this presentation, you should know what CQRS is, generally speaking, and what are the pros and cons of using CQRS in your application. Hello. My name is Wojciech Wrona. I'm a Ruby on Rails web developer. Most of you probably know me. So, to understand what CQRS is, we have to explain to ourselves what CQS is in the first place. So CQS is a principle developed in 80s, so it's quite an old, and it says that every method should either be a command, so something that performs an action in your system, or a query that returns data, the color, but they should never be both. So in other words, everything in your system should, in other words, when you are asking a question about something, that question shouldn't change the answer. Or more formally speaking, method should return a value only if it possesses no side effects. So your commands are the only way for your application to change its state, and your queries are only asking database and formatting, aggregating, and transformating it to show it in the most useful way for your frontend. And one example of violation of CQS in Ruby on Rails is this method, find or create by. It's active record method. So, it's active record method, we all can use it, but there is one problem with it. It don't always behave in the same way. And you are mixing two things. You are mixing your business logic, so how you want to create your objects, and you are with simple fetching from database. If you would like to apply CQS to that method, your result will be two separate methods: find by and create by. And it's good to keep this rule in mind, especially in Ruby, because Ruby is in Ruby everything is an expression, and everything returns a value, and it tends to bring hard to debug strange bugs. But as with most rules, it's meant to be broken in certain situations, so don't worry. And especially, it's meant to be broken, especially in dynamic languages like Ruby. So, if we already know what CQRS is, let's go a bit deeper. CQRS is something invented like 30 years after CQS was defined. It was invented by Udi Dahan and Greg Young, so two big names in IT industry. And the idea is that why do we split methods to queries and commands when we can design specific classes for that? So we can have classes that does only queries and only commands. So in other words, when we are speaking about CQS, we mean methods, and when we are speaking about CQRS, we mean objects. So CQRS is like applying CQS to the architecture of our software. So it's higher level CQS. So And one thing worth noting here is that the CQS, there is argument on the internet and everywhere whether CQS is a pattern or maybe it's an approach in programming. But in this presentation, we will stick to a version that this is a pattern. So if it is a pattern, you can apply it to only a small subdomain of your system, only to those subdomains that are complex or highly collaborative. And in that way, you can try it out on your projects without messing around. Okay, so that's how most of our application looks like now. We have some UI part, so things where, so our front end where maybe this is some kind of front-end application, mobile application, HTML views or something. It talks to our business logic, so to our some kind maybe service objects, maybe query objects or things like that, and to our models. And our models are connected to our database using some kind of ORM or ORM mapper. In our case, it's most probably Active Record. And and that's it. So, but there is one problem with that, because if you would like to apply CQRS here, our business logic and our models have more than one responsibility. They are both used for queries and for commands. So if you would like to so let's do something with that. Because the core rule of CQRS says that having one model is not enough for efficient work both of programmer and of the system. So we would like to split business logic to two, queries and commands. We would result in something like that. And now we should go to our model. But one thing worth noting here is that at that point we should change the name of our model to domain model. But because as a model I understand a group of containers for our data, and domain model is something a bit more. It encapsulates our essential business rules of our application. So, so despite the fact that commands are responsible for making changes in our application, essential core business rules should be placed still in domain model. But that's more a domain-driven design thing, so let's leave it for next presentations. And let's split domain model. We'll split it to read model and write domain model. So our domain model stays inside write domain model, and our read model is something smaller. It extracts only those things needed to query our database to get data from our. So it's used only for fetching, aggregating, grouping things. And in our case, both can be still mapped by ORM to some classes. Or we can try to move our read model to database level and use it as some kind of virtualized or materialized views on database and use simple SQL queries. That way we can get rid of select asterisk from selecting everything when we need only 2 columns. But for now, let's stick with the version with a separate read model. And okay, so now we have our models splitted, but only on the logic level, so only in our code. Let's move on. Let's split our databases. And now we can have 2 separate databases. We can have read database and write database. They are synchronizing themselves, so using events, but that's the topic of on next presentation. So let's leave it like that for now. The only thing you should know is that when it's done asynchronously, and it's done in a way that we shouldn't care that much about optimistic and pessimistic concurrency programs. Okay, so when we are in that place, we have tons of new possibilities. First thing that comes is that it's highly scalable, and you can have some different kinds of database for reads and for writes. You can have relational database for writing things. So you can have Postgres, which we are familiar with, and it's really good to use for writing things. And you can have maybe graph database or some RDBMC or something else on read side. But in most cases, you'd like to optimize your write database for writing. So probably have something like Postgres. and you would like to optimize your read database for reading. So you would like to probably to have something like NoSQL document database, like probably MongoDB or something like that. So you can place something like the normalizer in the middle of those two databases, and when they are synchronizing, you can denormalize the data when it's coming from one database to another. In that way, you can have really fast writes to your, for application, and you can have really fast reads for application, because when data are denormalized, you don't need any joins at all. So let's say you are Amazon, you have tens of thousands of users, and all of them are doing extensive hard query searches, which are producing hard queries with lots of joins. And it's easier to put data into your database because you are using just simple Postgres, and you have hundreds of read databases that are denormalized, so you don't have to use any joins at all. And that's why it's considered to be extremely highly scalable. And okay, here is how the normalization works, more or less. So when you have three tables with which are referenced each other, you can denormalize that, and in the normalized database you can have the same thing without joins, more or less. Okay, so what are pros of using CQRS? You have separations of your concerns and simplification of your domain model. So it's quite obvious because you are splitting everything. And you have extremely more ways to scale your application to increase performance. And your tests should be simple because you have simplification and separation of concerns. And cons are that it may be too complex for simple scenarios. So if your application is really simple, it may be really too complex to introduce CQRS to it. But on the other side, if you are developing simple application, you don't know if in 2 years it will be still simple or it will be complex. And cost of infrastructure can be higher, as you may need to have more database and so on. And that's it. Thank you. Do you have any questions?
How does it work so similar architecture, but it was about like master-slave replication. So you only write to the master, and guys who writes basically can read from the master, but other people can only read from the slave that are propagated. So does it also apply in this?
Yeah, it's something like that, but it's a bit extended because you are doing those events between databases. Because you will do synchronize, you will do ensure consistency between those databases synchronously. Then it will be useless because it will be slow as having many databases. And when you are using those events, it's like Git. You are just adding things to the database. So you can update them asynchronously, and but the downfall of that is that you are introducing eventual consistency. So your database aren't consistent, over time, but there is some cache between them.
Okay, so what do you recommend for the event system?
For event system, you can do.
Place to book is good for events.
I mean, you can store your
specific technology
for events.
Yeah. Like Rabbit.
Yeah, you can use some queue like RabbitMQ. It depends on your domain mostly, because if you need your events to be persistent, you would probably use something that is persistent. It's hard to say. I mean, there will be next presentation about event sourcing. It's specified on event sourcing, so on how those events should be sent and received and so on.
Okay.
I don't have exact answer for what's the best. Anything more?
You mentioned Asterix. What about Obelix?
He's not applicable.
So that's all.
Okay, thank you very much.